Okay, calculus. I uploaded a video on Monday reviewing the chain rule again. I went through all of the homework. As of 5 o'clock on Monday night, I haven't heard anything from anyone saying they're still confused. If you are still confused, you need to watch other videos, look up like Khan Academy or something, watch some of those. If you still have very specific questions, ask me. We might be able to do some kind of Zoom meeting or Google Hangouts or whatever to try and see if we can fix something. In the meantime, I'm going to move on to a very important topic called implicit differentiation. Implicit differentiation. When we do implicit differentiation, it's going to be important that you use Leibniz notation rather than using y and y prime in terms of expressing your derivative. The reason is if you use y and y prime, it's going to get confusing. Most universities, most professors really stick to Leibniz notation. It's the more accepted form of doing derivatives. You will very rarely see them put like y prime. They put dy over dx instead. So we're going to talk about what this implicit differentiation is and how Leibniz notation is going to work with that. So normally, when I get you to do a derivative, it's already in the form of f at x is, and then it gives an equation with x's in it, or y is equal to, and then it gives an equation with x's in it. But the y's and the x's are separated. They're not usually on the same side of the equal sign. So what happens when you have two different letters on the same side of the equal sign? So I'm on page 285 and I'm looking at example number 1. And they give the equation x squared plus y squared equals 100. And what they want to know is they want you to find the slope of the tangent when x is 6. So slope of the tangent means derivative. They want you to find the derivative or the slope of the tangent when x is 6. So let me just talk what that actually means in real life. This is an equation for a circle. X squared plus y squared equals r squared. That's actually a circle. So what they're saying is the center of the circle is actually at 0 and 0. The radius is actually 10 because that's r squared. And so they're saying if where x is 6, so let's say x is 6 right here. This is 6, so x is 6 right here. If I draw a tangent line where x is 6, what is the slope of that tangent line that I just drew? That's what they're asking. But I don't want to have to graph stuff, and probably neither do you. Hate to break it to you though, chapter 6, all graphing. One of the things you could do to solve this, is you could rearrange the equation. So I would have y squared is equal to 100 minus x squared. And then I could take the square root of this side and I could take the square root of this side, and I would have y is 100 minus x squared to the 1/2. Then I could do the derivative because I know my chain rule. And hopefully now that I've reviewed it, you do too. If I were to find the derivative, now I'm going to put this in Leibniz notation just so you get used to it. Instead of putting y prime, you put dy over dx. Now let me tell you what that means. it means you did the derivative of y, and the way they word it, and I don't know why it's worded this way, but it just is. You did the derivative of y with respect to x. I don't know why you're respecting x, but you are. But with respect to x, meaning x is the independent variable here. It's the unknown, right? X is 6. That's what we're doing. So to do the derivative using the chain rule, I would bring the 1/2 down in front. I would leave the inside alone. I would decrease my exponent by 1. And then I would do the derivative of the inside, which would be negative 2x. To clean that up, I would have negative 2x on the top. I would have a 2 on the bottom. And because that's negative, it goes on the bottom because it's a half. It is the square root of 100 minus x squared. So those 2's would actually cancel, and I would have negative x over the square root of 100 minus x squared. Now I could figure that out at 6, because I could do negative 6 over the square root of 100 minus 6 squared, which is 36. So 100 minus 36 is 64. The square root is 8. So this is negative 6 over 8, which reduces to negative 3 over 4. So the slope is negative 3 over 4. That's a lot of work to have to rearrange it first and then use the chain rule. There's another way that you could find the derivative, and you wouldn't have to rearrange the equation first. If you have two variables and they're on the same side of the equal sign, we can do what's called implicit differentiation. And again, I'm going to use Leibniz notation to do this. So, whenever you do this, you're going to do the derivative of each piece, okay? So, derivative of x squared is 2x. Now, technically, you did the derivative of x with respect to x. So technically, that would be dx over dx. And you'll see them, if you look at it in the textbook, you will see them write that. Okay, you will see them write that. I'm going to explain why I don't bother to in a minute, but I'm going to write it all out first. And then if I do the derivative of y squared, it's 2y. But this time I did the derivative of y with respect to x. That equals, now the derivative of 100 is 0, and technically I did the derivative of the constant with respect to x. Now, I never bother to put the dx over dx, because anything over itself is just 1, right? 3 over 3 is 1. 7 over 7 is 1. X over x is 1. So dx over dx is really just 1. So this is really, I don't know why I put a plus there, guys. There's why I put a multiplying, there's a plus there, sorry. So if I have dx over dx, that's really just 1. So this is really 2x times 1, which isn't going to affect anything. So I really, when I have dx over dx, I don't bother to put it, because I just find it confusing to put it there when it's just 1 anyway. So I don't bother with it. And if you don't bother with it either, that's fine. Now, this is not 1 though, because dy over dx, those are different things over each other. Like 1 over 2 is just 1 over 2. dy over dx is just dy over dx. And dy over dx is the same as y prime. So remember I said we're going to use Leibniz notation instead. Here's why. I could have said the derivative of y squared is 2y times y prime. But now I've got y's and y primes stuck in there, and people tend to not make the prime heavy enough and they don't notice it, or they think it's a 1 later on, and it gets confusing. So that's why they use Leibniz notation, but it really is the same thing. Now, again, I never bothered with the derivative of the constant over x. Why? Because whenever I do a derivative of constant, it's 0 anyway. So it doesn't matter what this is. 0 times this is just 0 anyway. So normally I would go right to this step. I wouldn't write this all out. I did it to show you because they have it in the textbook and I want you to see where that is coming from. But normally I would just go here. All right. Now, the whole point is to isolate the dy over dx. You want to get that by itself. So the first thing I'm going to do is I'm going to move this over here, and I'm going to have 2y times dy over dx is equal to negative 2x. I want the dy dx by itself, so I'm going to divide this by 2y. So I'm going to divide this by 2y so that those cancel. So I have dy over dx, and by the way, these 2's can cancel, is equal to negative x over y. Now I want to know when x is 6. So for x, I'm going to put in 6. Now your question is, but what do I put in for y? That's pretty easy because I actually can solve for that. I can figure out what y should be back up here. I can do, if x is 6, 6 squared plus y squared equals 100. So y squared is equal to 100 minus 36. So y squared is equal to 64. So y is 8. So I'm going to put 8 there. So all I did was to figure out my y, I just put x in here and figured out what y was. So I have negative 6 over 8, which reduces to negative 3 over 4, which is the answer I had before, but this time I did it without having to rearrange the equation first. So example number 2. Example number 2 says determine an equation of the tangent. So equation of the tangent means I'm going to do y minus y1 is equal to slope times x minus x1. So they want us to find an equation of the tangent to the curve x cubed plus y cubed equals 9 at the point 2 and 1. So there's an x and there's a y. So I already know y minus 1 and x minus 2. What I need is a slope. I can figure that out because I can do implicit differentiation with this. So I'm going to do the derivative of x cubed. That is 3x squared. Now again, I could put dx over dx here. I could say, by the way, I did the derivative of x with respect to x, but I don't need to because that's just 1 anyway. Plus, now I'm going to do the derivative of y cubed, which is 3y squared. But I have to say, I did the derivative of y with respect to x. So I did the derivative of the dependent variable based off of the independent variable. And that's equal to the derivative of 9, which is 0. Now again, I could put in, I did the derivative of the constant with respect to x, but I'm multiplying it by 0 anyway, so no point. So this is where I start. I want to get the dy dx by itself, so I'm going to move this over here. So I have 3y squared dy over dx is equal to negative 3x squared. So dy over dx is equal to negative 3x squared over 3y squared. So really I can just cancel those 3's. So I have negative x squared over y squared, and I have an x and I have a y. So negative 2 squared over 1 squared. Now that negative is not inside brackets, it's outside brackets. So 2 squared is 4, and there's a negative out there, so it's negative 4 over 1, which is negative 4. So I have negative 4 there. So I have y minus 1 is negative 4x plus 8. So y is negative 4x, and 8 plus 1 is going to be plus 9. That is my equation of my tangent line. Yay me. All right. Example number 3. There's only 4 examples. None of them are super long. Example number 3 says a satellite orbits Earth in an elliptical path described by the equation 2x squared plus y squared equals 36. Find the slopes of the tangent, so find the derivative, at the points negative 4 and 2 and negative 4 and negative 2. Okay, so they're saying find the slopes at those 2 points. So find the slopes of the tangents. So the first thing I have to do is find the derivative. So to find the derivative of this is 4x dx over dx, but I'm not going to bother to put that. Plus, bring this down, this is 2y, and I did the derivative of y with respect to x, and the derivative of 36 is 0. So 2y dy over dx is negative 4x. Divide both sides by 2y, and I have dy over dx. In other words, my slope is negative 4 over 2. Well, that's negative 2x over y. So they want me to find the slope at this point and at this point. So my slope is negative 2 times negative 4 over 2 for this point, right? For my x, I put in negative 4. For my y, I put in positive 2, which is going to give me 8 over 2, which is 4. My other slope for this point is going to be negative 2 times negative 4 over negative 2. So that's going to be 8 divided by negative 2, which is negative 4. So my 2 slopes are 4 and negative 4. All right. So in this one, even though they gave me 2 points, I just found the slope once and then just put the 2 different points in, the 2 different x's and y's. All right. Last one, and of course it's the longest one because it just is. So, example number 4, find dy over dx. So find dy over dx, which just means find the derivative, right? If you have x cubed plus x squared y plus 4y cubed equals 6. All right, don't hate me. I'm sorry. This is just what you do, okay? So if I'm going to find the derivative of this, I'm going to find the derivative of this, which is just 3x squared. And again, I could say that I did the derivative of x with respect to x, but there's no point to that. Here's where it gets tricky. Okay, so I did the derivative of that piece. There it is. This piece is x squared y, which means I'm actually multiplying 2 different things together. That means I'm going to have to do the product rule there. Yes, grown at your screens now. So the product rule is gf prime plus fg prime. So again, This is my G, this is my F. So, plus G, that's Y. I didn't do anything with the Y, so it's just Y. Derivative of F. Derivative of x squared is 2x. Plus, now we're going to leave F alone. We're going to leave that x squared alone, and we're going to do the derivative of G. We're going to do the derivative of Y. The derivative of Y is 1. But I have to say that I did the derivative of Y with respect to x. So all of that is the derivative to just that part. Okay. So now we have to do the derivative of 4y cubed. So I'm going to bring the 3 down. That's going to be 12. So it's going to be 12y squared. But again, I'm doing the derivative of y. So I have to say I did the derivative of y with respect to x. You don't have to put that little multiplication symbol in there. I just tend to do it so that it doesn't all run together. And then I have to do the derivative of 6, which is just 0. So now I have what appears to be a huge, huge mess. So what I'm going to do is 3x squared. I don't like that. I'm going to write that as 2xy. X squared times 1, that is just x squared dy dx. And that is 12y squared dy dx is equal to 0. All right, I need space, so I'm going to have to erase up a little bit higher. Sorry. So now I'm here. I'm trying to get dy dx by itself. That's what I'm trying to do. So I'm going to take any piece that does not have a dy dx attached to it, and I'm going to move it over to the other side. So x squared dy dx is going to stay on this side, plus 12y squared dy dx is going to stay on this side. The 3x squared is going to move over here, so it's going to be negative 3x squared, and the 2xy is going to move over here, so it's going to be minus 2xy. So now I have this. So now when I look at this piece and I look at this piece, what is common, or what is the same about both of them, is they both have a dy dx in them. So I'm going to take that out as a common factor. What I have left is x squared plus 12y squared, and on this side I have negative 3x squared minus 2xy. So now I'm here. I'm getting closer. I need to erase this again. So remember, I'm trying to get the dy over dx by itself. Right now I'm multiplying it with this, so I'm just going to divide this side by x squared plus 12y squared. So I'm going to divide this side by x squared plus 12y squared. So dy over dx is equal to negative 3x squared minus 2xy all over x squared plus 12y squared. In the textbook, they take the negative and they put it out front here. I don't care. It's fine where it is. Just leave it there. That is the derivative, okay? So you might have to watch this video a couple of different times. Again, if you are struggling, I am not the only voice that explains this on the big wide interweb thing. You can look up all kinds of different people explaining this, some who more than likely explain it way better than I do. So you can check those out. If you're struggling, you can ask me questions if you're struggling. Try some though, watch this video a couple of times, see if you can't figure it out. If you have questions, please let me know. I'm going to post some questions that you can try for this, all right? So I'm just looking ahead here. Yeah, I'm looking at probably mid to late next week we will be finishing chapter 5. So mid to late next week, finishing chapter 5. Okay, guys? So we're moving into related rates after this, which is word problems. So make sure that you really get this before we move on to related rates. So please, if you're having trouble, if you're needing help, please let me know. All right, talk to you soon.